Students, is my screen visible?
Yes, ma'am.
And okay. So, good evening, everyone. I am Rakhi Yadav, your PMRF teaching assistant for Introductory Organic Chemistry course, which is conducted by NPTEL and whose course instructors are Professor Harinath Chakrapani and Professor Neeraja Dashaputre from ICER Pune. So, students, in last week 5, what we have covered is chemistry of enol and enolate chemistry, right? So in this class we are going to cover some reactions which are based on carbonyl compounds such as aldol, Cannizaro, etc. Okay, so before moving ahead, let's solve the question which we have solved in last class. Some were in this in all these four options, which option I have given you as a homework? Can anyone please remind me? Okay, the question was in which of the following equation is the main product wrong? First one is clear or not?
Yes, ma'am. Clear.
Okay, just give me 1 minute. Students, just wait for 2 minutes, okay? Yeah, now it's working. Okay, so in first option number A, simple. This acid is going to activate your ketone, right? After activating it, OAC minus is going to abstract this proton, right? And it will form your enolate. Not enolate, enol. Why enol? Because it is acidic media, right? Clear? Then what will happen? Br2 is there. This enolate will come back and attack your Br2. And what you will get? Right? And at last, removal of minus HBr. How minus HBr? H plus from here and Br negative from here, right? So you will get alpha brominated product. I hope this mechanism is clear to everyone. Yes or no?
Yes, ma'am.
Okay. In second step, what? What is this? This is equivalent of your HCHO. Okay. So obviously base is going to abstract this proton. Okay. It will form enolate, and that is going to attack your aldehyde and you will get this product, right? No heat is there, so you don't have to draw condensation product. Okay. You have to stop to beta hydroxy product. This I was talking about is Claisen reaction. How you are going to do it? One, 2, 3, 4, 5, 6. Now the question arises, from which side you should you should abstract proton, this side or this side? But we can see this molecule is symmetrical. Yes or no? So let's say base is abstracting proton from here, and it will become carbonyl after abstraction of proton, and it will attack this carbonyl. Six member ring will form. Just do numbering: 6, 5, 4, 3, 2, 1. On 6 number carbon, O minus OET. Right? 5 as it is, 4 as it is. At 3, this one, second, no substituent from 1, CO2 ET is there. Always do numbering, it will make your life easier. Okay. As you can see, at carbon number 1 this CO2 it is substituent is there, so I have put it as it is. Now O negative will come back. Obviously it will eliminate this OET minus, right? Because instead of carbon bearing negative charge, oxygen bearing negative charge is stable. Therefore this OET will knock off and you will get beta keto ester. This is example of which name reaction? Tell me, students, which name reaction is this? Claisen intramolecular Claisen condensation reaction. Okay, and at last you have this, where I have told you that this is not that much electrophilic carbon, this alkyl halides. Therefore, whenever you are having alkyl halides, an alkylation takes place. But here, C alkylation has been done. Therefore, a question is asking which main product is wrong. Therefore, correct answer is D. Since main product is wrong here. This was recap of last time question, as I have solved that question in hurry. Now, is it clear to everyone?
Yes, ma'am.
Okay, good. So next problem is this. Uh, have we have we done this question or we have to do? Can anyone remind me, please? We have to solve or we have done in last class? Okay, we will solve again. Again, in first case, your base is there, right? So base can't abstract proton from this aldehyde, so it will abstract your ketone alpha hydrogens, CH3CO CH2H. So base will come, abstract this proton, and it will make your enolate. O negative. Always write counter cation whenever you are writing mechanism. Okay. Then you have benzaldehyde in your medium. This negative charge will come back and it will attack your aldehyde, right? O C O H P H. Clear, students, till this point?
Yes, ma'am.
Okay. And at last, Okay, at which point will you stop? Hydroxy point, or you will do condensation reaction?
And hydroxy.
Are you sure?
Ma'am, maybe condensation because H3O plus is there.
Exactly. You are also right, but here H3O plus is there, right? It will protonate your beta hydroxy group, and it will abstract this proton and it will eliminate. So the product you will get is, now the point comes whether it will form E alkene or Z alkene. So obviously it is going to form your E alkene because they are more stable. Clear? So correct
Yes, ma'am.
option is C. Okay. Okay. What about this question? Okay, it is asking which of the following reactions, okay, which of the following reaction shows a correct main product? Okay. So in first option, is it correct product? Okay. Before solving, tell me the name of reaction, then tell me mechanism. I am also solving, you please start solving with me. CH3, CH2, CO, OET. Student, whenever on arrow two things are given, you have to interpret that ETOH, THF, these are solvent, right? So ethanol is nothing but here solvent, and this OET negative, we can call it ethoxide ion, sorry, this will act as your strong base. So first step of a base is to abstract a proton. So okay, my first question to you, which is most acidic proton in this entity? Okay, let me label A, B, or C. OCH2CH3. Which is most acidic proton? Have you understood my question? I'm asking which is most acidic proton in this? Okay, let me write.
Ma'am, A.
Obviously A. CO, O, CH2, CH3. Okay. So this proton will be more acidic as it is attached to alpha carbon, right? This can do conjugation with this oxygen. Okay. So therefore, what you will get is, you have two molecules of this molecule, right? CH3, CH2, CO, O, ET. If any point it is not clear, please ask. And then that enolate is going to attack your carbonyl, and what you will get? Double bond O, O, C, O negative, OET, CH2, CH3. Okay. Now O negative will come back. Obviously, it will knock off this OET negative minus OET, and you will get CO. Clear, students? Is this product is similar to this? Let's see. CH3 CH2 CO. Okay. CH3 CH2 CO. Then 2 CH2. But here CH3 is there. Okay. CO2 ET. So is option number A correct or not?
Yes, ma'am, correct.
Correct. How?
No, ma'am, not correct.
Not correct, na?
Yes.
The okay. Who was that person who was saying correct? Am I
Yes, ma'am, I told by mistake.
Okay, okay. I thought I have done somewhere mistake.
No, ma'am,
You
no,
all
ma'am.
are getting this product, right? In this product, this active methylene carbon have one CH3, but here no CH3 is there. So option number A. Question is asking correct main product, but this is not correct main product. So option number A is wrong. Okay. Okay. Now let's come to option number B. And student, whenever you are having lithium bases, okay, these are quite bulky base, and base is bulky, temperature is low. Obviously, they are going to form kinetic product, but here they have formed thermodynamic inolate. Kinetic will be I think this I have told you in last class. Yes. Why this is kinetic product? Because if let's say base is here, okay, it has to abstract this proton, it has to abstract this proton. Which is more easier for a base to abstract? Obviously, proton A. Why? Because they are least sterically hindered. Okay. Therefore, at low temperature, whenever bulky bases are there, you have to form kinetic inolate, not thermodynamic inolate. So therefore, option B is also wrong. Okay, potassium hydride. Remember, potassium hydride will make your thermodynamic inolate because it is very, what I will call it, H negative has
Unstable.
very small size, right? So it will form your thermodynamic inolate. It will form inolate which is more stable, and stable inolate is this. Why? Because it has more hyperconjugation, or I can call it more substituted bond is more stable. Okay, so this is correct product, so option number C is correct. What about option D? Option D, I have told you, here positive charge is not that much stable, so instead of C alkylation, O alkylation will take place. Only reactive, listen this thing, only reactive alkyl halides will undergo your C alkylation. Okay. Now ask me what doubt you are having. Are all options clear to you? Why option number A, B, and D are not main product?
Yes, ma'am.
Okay, very good. Okay. Now a new name reaction came into picture, that is your Cannizaro reaction. So right condition for Cannizaro reaction, first it should be aldehyde. Second, it should not have alpha hydrogen. Okay. These two conditions are must. Now if we talk about mechanism, I am just giving you simple picture of Cannizaro reaction. Student, whenever you are having aldehyde which is lacking alpha hydrogen means hydrogens attached to your alpha carbon, alpha to alpha with respect to carbonyl. Okay, here they are absent. And on arrow, whenever it is written concentrated NaOH, okay, concentrated NaOH means you have plenty of OH negative. Now let's see its mechanism. Students, base is there, but do we have any acidic proton in our starting material, which is a aldehyde, formaldehyde?
No, ma'am.
Okay. So only thing that it can do is nucleophilic attack, right? O minus OH. Till this point it is clear. Now what will happen? You have to take two molecules of this molecule. You have another molecule also, remember. Now there are two things. This O negative charge can come back and it can eliminate OH negative. But by that you will get back to your starting material, right? This O negative will come back, OH negative will leave, and you will get your starting material. But will it be possible? Okay. Can anyone tell me what is Leach-Atelier principle? You have studied this, I think, in equilibrium, ionic or
Yes,
chemical.
ma'am.
Huh. So, according to that, in question they are saying that you have plenty of base, concentrated NaOH is there. So, obviously, reaction will go in forward direction in order to decrease the concentration of this as per Leach-Atelier principle. Okay. So, obviously, this O negative will not come back and will eliminate this OH negative because it will get back to its starting material. So only option it have is removal of H negative. Now this H negative is going to attack second molecule of aldehyde, and you will get HCO OH H H O negative. uh, Correct na? Huh. Now you have acid in your reaction vessel, you have alcohol in your base. Now obviously this O negative will abstract this proton from here, and at last what you will get? HCO O negative plus, you will get this alcohol. Right or wrong? Correct na?
Yes, ma'am.
This point is clear why. Okay, let's say you have to keep this charge. Remember, this charge is with your sodium cation. Okay. Now, remember, on which oxygen this negative charge is stable? On A, in case A, or in case B? Obviously, in case A, this negative charge is stable because it can do conjugation or it can do resonance. Therefore, this second molecule act as a base, abstract proton from acid, becomes alcohol itself, and one molecule get oxidized and one molecule get reduced. So, students, Cannizaro reaction is also known as Cannizaro, also known as disproportionation reaction. Why disproportionation? Because same molecule get oxidized as well as reduced, because reduced structure of aldehyde is alcohol, and oxidized version of this aldehyde is acid. Okay. Now tell me, is mechanism clear to everyone? If not, I can repeat.
Yes, ma'am. Clear.
Okay. If clear, you just tell me yes or no. Okay. Compound A, will it go Cannizaro reaction? Yes.
Yes, ma'am.
Yes, ma'am.
I want answer from everyone, not only these two students. Okay. B,
Yes, ma'am.
Yes, ma'am.
yes. Okay. C,
No.
No, ma'am.
why? Because it can undergo aldol
Alpha for.
reaction. Because whenever base, why the condition is it should not have alpha hydrogen? Because if it will have alpha hydrogen, then so it will go undergo normal aldol reaction, right? Base will abstract proton, it will form inolate, attack onto it. D,
No, ma'am.
okay. E,
Yes, ma'am.
Yes, ma'am.
okay, good. F,
No, ma'am.
no, okay. G, these
No,
are
ma'am.
these are alpha hydrogens. Okay, so no. H,
Yes, ma'am.
yes, because
Yes.
this is attached to this carbon, and this carbon do not have alpha hydrogen. Okay, see, 1, 2, 3, 4. Four valencies are complete, so no alpha hydrogen. 1. Sorry, not 1.
Yes, ma'am.
I. Yes. Yes. J.
No,
G.
ma'am.
No, ma'am. No.
K.
No, ma'am.
No, ma'am.
Alpha hydrogens are there. L.
No.
No, ma'am.
Okay. M.
Yes. No.
No, ma'am.
No.
Who told me yes? Okay.
Ma'am, it's by mistake.
Okay. I can understand. N.
No, ma'am.
N ka
No,
N.
ma'am.
So understood now which type of question they will ask in your Cannizaro reaction. So you have to identify only like this. You have to see if compound is having alpha hydrogen or not. Huh. Okay. Okay. Problem number 5 is students find out the aldol reaction. Okay, aldol reaction. What they are asking? Only one, only two. Okay. Okay, student, in first question they are asking, is this product possible? This 3-hydroxybutanol. Okay, let's see one by one. This is your base. Base is going to abstract this alpha hydrogen. It will form your enolate. You have another molecule. This enolate is going to come back and attack your another molecule. It CH3CO negative H C. Clear? Okay. And at last, protonation will be done after workup and you will get this product. So CH3, COH, CH2, CO. Yes. So option number 1 is the correct, student. Are you with me? Is option.
Ma'am, but here the product it is wrong. It
Huh.
will be methyl group attached to C double bond O. Here hydrogen is
Okay.
attached.
Very good. So here, as per our, we have written correctly here, but good observation. Very good. So this product is wrong. Very good. Okay, why? Because as per our mechanism, at terminal position, methyl is there, but here they have formed aldehyde. Good. Okay, so in option number 2, again let's write mechanism. First make inhalate. It means students are awake. Okay, correct na? C, CH3, CH3, OH. Is this the product? CH3, CH3, OH, CH2,
Yes,
CO.
ma'am.
Yes. Actually, I have seen till this point, and after that, I have not seen. Okay, good observation. So, only option number 2 is correct. Is it clear to everyone? Other people say yes or no, or should I
Yes,
explain
ma'am.
again? You just have to make inolate and attack on another molecule. Okay. Okay, good. Who is going to solve this problem? Before solving, tell me, aldol reaction will take place or Cannizaro?
Aldol.
Aldol. Okay.
Aldol.
So first answer is correct. Aldol reaction will take place. Okay. Now second question is, which is most acidic proton? Okay, let me label A, B, C. there is no significant difference between acidity of these hydrogens, right? So what we can do is we just do one by one. Let's say if you are abstracting proton from b carbon, okay, so how many member ring will form? 1 2 3 4. As per Baldwin rules, 4 member ring is possible or not? Students, till 4 member rings are not stable, okay, because ideal sp3 angle is ideal sp3 angle, students, 10.
9 1090.
Clear na? But in your what I call is 4 member ring, this angle is 90 degree, so too much angle strain is there, right? So therefore, 5 membered rings are more stable than your 4 member. And in 5 or 6, it depends on situation. But here, one thing is clear, it will not abstract proton from this side. Okay. Okay. Now, if we abstract this proton, how many member ring will form? 1, 2, 3, 4, 5, 6. This is possible, right? So let's do it. So first, we will make every possibility. Please tell me if I make mistake anywhere. Okay. COCH3. Clear. Okay. If it abstract proton from here, just do simple numbering 1, 2, 3, 4, 5, 6 and form ring here. Okay. 5, and this is your carbon number 6, on which one is your O negative. Okay, here it will come one carbon number 1, at carbon number 2 carbonyl is there, 3 4. Students, first tell me, is this numbering part clear to everyone, how I am doing numbering? If not, I will explain you again.
Ma'am, please explain.
Okay, okay. Good. You can ask now. See, you have to see from which, okay, in aldol reaction, whenever intramolecular aldol reactions are there, you have to see how many different types of acidic protons are there. Okay. Acidic protons where you will get alpha at alpha carbon. Okay. So when we see possibility B, there it is not possible because it will form 4 member ring. One, okay, let me use this. 1, 2, 3, 4 member ring. So cut this option. Another option is this, that proton abstract base from this terminal carbon. Here you will get carbanion 1, 2, 3, 4, 5, 6. This carbanion is going to attack your carbonyl. Mechanism is clear? Clear or not?
Clear, ma'am.
Sodium hydroxide is there. It is base what is the role of base? To abstract a proton. In all this system, which is most acidic proton? Obviously hydrogen attached to your alpha carbon. Why? Because they can be in conjugation with this oxygen. From left side it is not possible because it will form 4 member ring. From right side it is possible, and if it is possible, just do numbering onto carbon from where you are picking the proton. So carbon number 1, 2, 3, 4, 5, 6. Why 6? Because onto this carbon this hydrogen is going to attack. If I write it like in this way, CH2H, okay, this is your carbon number 1. So base will come, abstract this proton. It will become your carb anion. Now this carb anion is going to attack this carbonyl. Okay. So on after attacking, it will become CO negative. Methyl was already there. So methyl is already there. Then as we have done numbering, you please solve in your copy with me. Okay, it will help you. Do numbering. It is carbon number 5, 4, 3, 2, 1. After making you know that 6-member ring will form. Let me draw it here in a better way. Let me try. Done. Now you know that on carbon number 6, one methyl is there. So, okay, let's draw one methyl. Since it has attacked that carbonyl, it will become O negative, and this attack is from this carbon. Okay. Okay, carbon C double bond O. At carbon number 3, nothing was there. At carbon number 4, one methyl was there. Carbon number 5, and this is your 6. Is this clear?
Yes, ma'am.
Okay. Let me show by like this. This this is new bond which you have formed via aldol reaction. Yes or no? This bond. Here earlier it was carbanion, is it just attacked this carbonyl. This is intramolecular version of aldol reaction. Clear, students?
Yes, ma'am.
Okay, good. Now what it will form? Draw this part as it is. It will take OH, it will become OH after your workup and all. See, heating is also there. So now you can tell me, you will tell me actually, from where dehydration will take place. How many option it have for dehydration? Only one. Because for H2O to leave, this carbon doesn't contain any hydrogen, right? So only possibility is you will get this product. All of you have tried making this molecule, right? I hope everyone is getting this product. If not, just tell me.
Yes, ma'am.
Clear?
Yes, ma'am. Clear.
Very good. Now tell me what is other possibility? One more possibility is there. One more possibility is that this proton A is base will abstract this proton, and now how many member ring will form? One, two,
5.
three, four, five, six. Again 6-member ring will form. Now let's check what we are getting in that condition. Okay, and then tell me
Ma'am,
which is major. One product is this. Let's lock it. A. Another possibility. Let's check. Yeah, someone was asking something. Ask.
ma'am, you have modified the question as you have represented the A.
No, I have not modified the question. Where you are thinking?
Uh, Ma'am, add the starting material where you have drawn in the red that is not actually already present in the black.
I'm still not getting where you are having that doubt. This is your A proton, right?
Yes, ma'am, I asked it that one.
This I am just asking for that. This is, let's say, A proton. I was asking now which is most acidic proton. Okay, just wait. This is your simple methyl. This methyl. This is methyl, nothing else. Now clear?
Yes, ma'am.
Sure, na?
Yes, ma'am.
Okay. Now another possibility is that it will abstract proton from this carbon and make carbanion here. Okay. before I draw this, draw in your copy and you will get confidence over it. Okay. Now just do simple numbering. 1, 2, 3, 4, 5, 6. And attack this carbanion onto this carbonyl. In enolate chemistry, aldol type of reaction, you just have to make carbanion and you have to attack the carbonyl group. That's all. Your job will be done. Okay. Six member ring, na? So just make six member ring. Okay. Then do numbering. 2, 3, 4, 5, 6. O negative. And this is your carbon number 1. Is something left here? Quickly. One thing I have missed.
Ma'am, double bond O.
Oh, exactly. At
Oxygen.
carbon number 2, double bond O. So clear till this point?
Yes, ma'am.
Now heating is there, it will take proton from your work up and all. Now there are two conditions. Actually three conditions. Yes or no? It can students, it can abstract proton from here also. But this will not be stable, okay, as it will not be in conjugation with your carbonyl. Understood? I'm talking about which proton? This CH2H. This is also alpha hydrogen, right? Here, from here also it can eliminate water molecule. But final product will form where it will be in conjugation with this carbonyl. Okay. But here in this case it is having possibility from both side. Obviously it will form from this side in order to gain conjugation. Conjugation brings stability to your product. CO, methyl. Okay. Now tell me student, this is B product, this is A product. Which is more stable? Which is more stable and can you tell me are these products same A and B?
No, ma'am, not same.
Not same.
Um, A will more stable.
B is more stable. Okay. Uh, Tell me with reason. One thing is clear, A and B are not same. Why? Because here after CH2, C double bond C is there, and here after CH2, C double bond O is there. And if we talk about this alkene, this is having equal number of resonance and hyperconjugation. Same in here. Now tell me. So student, in this case actually both products are possible. Because why? Because we can't compare acidity of this proton and this proton. They will almost be similar, right? If first step in aldol reaction is abstraction of proton, so in that criteria both are following the conditions, both are forming six membered ring, both are having alpha hydrogens that are almost equally acidic. So now final call is with stability of product, but stability wise also both the products are almost similar. No, not similar, stability wise they are similar. Understood? So both products are possible here. Is it clear to everyone?
Yes, ma'am.
So in aldol reaction, you should draw every possibility. Okay. Okay. Identify the principal product of the following reaction. Okay. ठीक है. Okay. Which reaction is possible here? Aldol or Cannizaro?
Aldol.
Aldol, obviously, because it is having alpha hydrogen. So draw, make inhalate, attack. I am also making. You start doing yours. Clear? Let's say you are taking proton from this side. Okay. Now you don't have any. Okay, you tell me. How? Okay, tell me how many member ring will form?
5.
Exactly, five. Okay. So after doing this, just make five member ring. See, students, whenever you are doing intramolecular aldol, please do numbering. It will help you. Otherwise, you will miss some substituent there. Five. Okay. So this is your two, three, four. On five, it is attacking O negative, H. One is this, and this is your CHO. Clear? And at last, students, ethanol, water. Ethanol is your solvent. Water for workup. This is base. Under heating condition, it will undergo condensation reaction.
Ma'am, please explain the CHE.
Could you please repeat? I couldn't hear.
Ma'am, can you please explain here is the CHO, CH4.
Okay, C. Okay. My bad. CHO is your aldehyde. C double bond OH. In short, we write it like that. Uh, let's
From
say here
where it
substitute.
comes?
This is CHO. CHO is attached to this carbon. Now clear?
Yes, ma'am.
Is this product clear? So which option is this? Option number
B.
B. I hope it is clear to everyone. CHO is nothing, student, but this. Okay. Problem number 8. The enolate ion that reacts with 3-butene 2 on to form Y is. First take 30 seconds and read this question and tell me what it is asking. They are asking among these options which enolate ion will react with in their 3-butene, okay, 3-butene, 3-butene, 2 on. Clear? This is your 3-butene 2 on. 1, 2, 3, 4. 3-butene 2 on. Clear, students? this 3 butene 2 on is also known as your what? Methyl vinyl ketone. Okay, good. Now they are saying in order to form this product, one way is you can do option wise option. Other ways you can do retro here only. So let's go by option. If option number A is your enolate, it will remember this thing, students. Whenever you are having this alpha beta unsaturated system, they will attack in 1,4 fashion. Why? Nucleophile will attack here. Actually, it depends what conditions are there. In general, whenever you are having organolithium salts, it depends. These salts are of which? I what I want to conclude is whenever you are organolithium salts like RLI, they do 1-2 attack. 1-2 attack means they attack your carbonyl. Whenever you are having organocuprates, they prefer 1-4 attack. And whenever you are having your Grignard reagents, RMGBR type, they do 1-2 attack. This all things are depending on HSAB principle. Okay, tell me where there is more electrophilicity at carbon number 1 or carbon number 2, where there is more electron deficiency. If I am having this molecule, students, this is your carbon number 1, this is your carbon number 2. Tell me where the carbon is, where the density of positive charge is more, on carbon number 1 or 2?
One.
1, exactly. So, where there is more electron deficiency, that will be your hard center, and this will be your soft center. Or we can call it this is your hard acid, this is your soft acid. This thing clear how to assign hard soft on basis of density of that charge. Not density, intensity of that charge. Sorry. Okay. So one thing is clear. But if we talk about these R negative, or let's say R2CuLi, Gilman reagents, R negative. In all these things, student, this is your softest nucleophile. Organocuprates are softest. This is your hard nucleophile. So as per HSAB principle, hard hard acid is going to attack your hard base, okay, and soft acid will react with your soft base. Clear? So obviously, when your RLI is there, which is hard nucleophile, it will prefer hard center to attack. Okay. And whenever you are having organocuprates, they are softer nucleophile. So they will obviously attack your conjugated position. So whenever you are having alpha beta unsaturated system, if cuprates are there, attack at here, carbon number 4. And if organolithiums or Grignard here, do 1-2 attack. In general, not always, in general. Clear till this point?
Yes, ma'am.
I'm not sure.
Okay. Now someone will have doubt, ma'am, how organolithiums are hard nucleophile and how organo. This is doubt, right? So, among copper and lithium, which is more eager to go in that monocationic form, Li positive, which is more eager, which is in more hurry?
Lithium.
Obviously, lithium, because after leaving that one electron, its configuration will be it will attain noble gas configuration, right? So therefore, that negative charge intensity is more on R in case of lithium than your cuprates. Yes or no? So wherever charge intensity will be more, that will be hard, and wherever it is less, that is soft. Acid, where there are positive electron deficient center, they are acids, and where there is electron density, that is base. This is simple hard acid, hard base, soft acid, soft base. HSAB principle. I hope it is clear. This hard soft term we are giving on basis of that intensity of charge. Here in this case we don't know where it is, but since in product both are carbonyl, so one thing is clear, that it is doing 1,4 attack. Okay, now let's do one by one. This was your methyl vinyl ketone. You can ask me at the end of the class if still some doubt is there. Okay, let's make it attack here. I will do option number A for A and B. You guys do C and D and tell me which enolate ion will give me Y. You can do cheating how I am doing and start solving. Okay, student, can I rub this right side part? You can take
Yes, ma'am.
screenshot. Huh.
Okay.
Okay, which option you are getting? Okay. So student, after getting to this point, after doing workup, it will become like this. Now again base is there in your medium. It will abstract proton from this side. Why not from this side? Because from here 1, 2, 3, 4 member ring will form. That is not stable as per Baldwin's rule. So obviously proton will be abstracted from here 1, 2, 3, 4, 5, 6, and you will get O negative. Clear how I have done this? 6, 5, 4. Okay, some mistake I have done. Carbonyl will come here. 3. Is this clear how I have made that? Now it will become OH, and obviously it will eliminate which side proton? This side. So it will be like this. Is it clear? Formation of this in case A. If I have done mistake anywhere, please tell me. Before telling, just tell me, is this mechanism clear how I have drawn? Student, give me some response so that I can move ahead.
Ma'am, please explain the last step.
In last step.
Yes, ma'am.
Okay, okay. Just give me 1 minute. So in last step, student, this is O negative. After workup, it will become OH, right? And in heating condition, it will undergo condensation reaction. 1 mole of water will leave. OH is there. It can take proton from this side. It can take proton from this side as well. But why it will take this proton? Because now this double bond will be in conjugation with this carbonyl. So just 1 molecule of water is left. From this carbon, it will leave as OH negative. So it will leave here positive. This will leave as H plus. So it will leave here negative. You will get an olefin. Right?
Yes, ma'am. Clear.
Yes. Good. Now tell me, will B give me this? Okay, let's do. Let's do for B now. I urge you before I solve, you solve for B. Okay. In B, what you will get? CO. Okay. And then this is your. Okay. And if we see again, it will form 4 member ring. So, no, it will first become like this. Now, 1, 2, 3, 4, 5, 6. Do numbering 6, 5, 4, 3, 2, 2, and 1. Clear? Now it will become OH. It will abstract proton. Are you able to solve with me? And you will get this. In option number B, students, you will get this. Now let's go to option number C. Option number C, I will directly draw C double bond O, C double bond O, methyl, and here you will get this. Now, 1, 2, 3, 4, 5, 6. Let me take another pen. C double bond O, C double bond O. I hope you all are solving with me. 1, 2, 3, 4, 5, 6. So 6, 5, 4, 3, 2. On carbon number 2, 1 O minus will form and 1 CH3 is there. No, no, no. We have done mistake here. On carbon number 2, carbonyl will be as it is, and this carbon ion has attacked here, right? So you will get this, and one methyl is also there. After workup, it will be protonated, and now it will abstract proton from this side, and it will form your this product. So correct answer is option number C. Is it clear? Now can you form product after enolate D attacks on methyl vinyl ketone? Can you do or not?
Yes, ma'am.
You all have understood, right, how I am solving? First do attack. Then after workup, it will become ketone, simple ketone. Now again base is going to abstract that proton and it will form six member ring. This is the cycle for this reaction. Only doubt you can ask is, ma'am, why it is not directly attacking from here only? Because from that side it will form one, two, three, only four member ring, which is not facile. Okay, good. Problem number 9. Okay. First reaction is which name reaction? Have we covered pinacolone type, pinacolone rearrangement type reactions? Actually, it is not that. Okay, H plus is there. Obviously, if you have this molecule, H plus is going to protonate your alcohol, right? And it will become a good leaving group. So after it become a good leaving group, it will form carbocation. Now, can this carbocation be more stabilized by anything, by any sort of rearrangement or something? Yes, by ring enlargement. How? If this bond can break. If this bond will break, positive charge will come here, right? I'm just writing for your sake of understanding. Positive charge will come here and negative charge will come here if this bond break. This positive will combine with this 1, 2, 3, 4, 5, 6. A six member ring will form. Yes or no? This is your carbon number 1, 2, 3, 4, 5, 6. Good. Now on carbon number 2, one methyl is there. Positive charge will come as CC bond migration has taken place, and you will get this. Clear? And after, since heating is there, if whenever you are having carbocation students, there are two possibilities. One is nucleophile will come and attack onto this carbon. Okay. Another possibility is elimination. And after elimination, you will get this product. Is first step clear to everyone? This is actually carbocation rearrangement, which I have not taught you, but I hope you have understood how I have done this rearrangement. Whenever you are dealing with carbocation chemistry, you have to make that carbocation maximum stable in that compound. Okay. Here it was primary carbocation was not stable, right? So therefore this CC bond migration has taken place. How? If this bond will break, it will become positive, negative. In carbon carbon bond, if heterolytic cleavage take place, one will become C positive, one will become C negative, right? Clear na? Same in same way it has happened here. Just say students yes or no. If not clear, I can
Yes,
explain.
ma'am, clear.
Good, good. That what I want to.
Ma'am, please explain it once again. I
Okay,
am not.
okay. See, student, this is your alcohol. Okay. First, protonation will happen. After protonation, this will become a good leaving group H2O. Obviously, it will leave as a neutral molecule. So how it will become neutral? If this bond will break like in this way, in this way, right? Because negative positive neutral, and it will leave here as a H2O molecule. So obviously it will leave here a positive charge. Is this thing clear, student?
Yes, ma'am.
Huh. Now another thing that is left is, now what will happen? So it is having two possibility. Have I done somewhere mistake? Is it correct, right? Huh. Actually, these were on same carbon. Till this point, clear how I am forming this carbocation, student?
Yes, ma'am.
Huh. In one class, I remember I have told you how to see stability of carbocation. First by mesomeric, then aromaticity, resonance, hyperconjugation, inductive. Here, student, it is primary carbocation, not that much stable. So this carbocation wants to get stabilized. How it will stabilize? By shift. Here hydride shift can't take place, so here bonds CC bond shift will be happening. So if this bond breaks, it will break like, I am just making this thing for your understanding, okay? You should not draw like this. If this bond break, it will be like positive negative. This thing is clear for your understanding. Now, obviously, these two bond will meet. Positive, negative will meet, and will form one carbon-carbon bond, right? How many member ring will form? One, two,
Six.
three, four, five, six. After forming carbon-carbon bond, the charge vanishes. Clear? And you will reach to this structure. Tell me yes if you understood till this point.
Yes, ma'am.
Very good. Now, student, I was telling, whenever you are having carbocation in your reaction medium, it can do two reactions. One is any external nucleophile will come and attack onto this carbocation. Another is elimination. Elimination can take place from either side. Elimination means it will, one H plus will go, negative charge will come, and that positive negative will form this olefin. Clear? I hope you are clear that compound A is this. No doubt in that compound A.
Yes, ma'am.
Good, very
Yes,
good,
ma'am, clear.
good. Now, student, it is very simple. Simple ozonolysis reaction is there. Do cleavage. I have told you earlier also how to do ozonolysis reaction. Solve before me. This is my product B. Clear? Now tell me, B to C, which reaction is this?
Ma'am, aldol.
Exactly, intramolecular aldol. Now again question arises, from where we should abstract proton. Here it is clear, one side we have aldehyde, one side we have ketone. But one thing is there, which proton to abstract, proton A or proton B? Just see how many member ring is forming. If you are abstracting proton from B side, so 1, 2, 3, 4, 5. If you are abstracting proton from A side, 1, 2, 3, 4, 5, 6, 7. So students, 5 member ring is more stable than your 6 member, than your 7 member. Remember this thing. So obviously for aldol I am telling, okay, for aldol. So in here, this proton will be abstracted. Carboanion will form here. It will attack this carbonyl and will what it will form? O negative. This will be as it is. O negative will take water from medium. Heating is also there. and you will get this. Am I clear to everyone? And which option is this? Option number C. I hope this question is clear. It was good problem, right?
Yes, ma'am.
Other student, if clear, can I move ahead? Boys, just say yes or no.
Yes, ma'am. Move.
Okay. Okay, this question is interesting. If you all have understood Cannizaro mechanism, you can tell me. Okay. My first question in this question, where that OH negative is going to attack on LD. This is actually a problem from mixed Cannizaro. In general, two molecules of aldehydes are taken, but here they are not same, they are different. Now question arises, where to attack that OH negative among HCHO? This is a question from your general organic chemistry. CHO, OME, OME. Now tell me student, where will this OH negative will attack? Onto this or onto this? Aldehyde 1 or aldehyde 2? If 1, why? If 2, why? Very good. It
Ma'am, in one.
1. Okay. She's saying 1. Boys, what is your take on this?
Ma'am, one actually.
1. Why you all are saying 1? Because carbon number 1 is more electrophilic. And student, remember in Cannizaro reaction, what is your RDS? Attack of that
Right.
nucleophile. Actually, RDS is hydride transfer also, but attack of nucleophile is also a key step here. Okay, so obviously nucleophile will attack onto that carbon which will be more electrophilic. This carbon is conjugation with these. Instead of that, it is having two OMe groups also, which are plus M, decreasing the electrophilicity of this carbon. Okay, you are attacking this. Clear. Now what it will do? It will transfer that hydride to CHO. I'm not drawing that OME part, student. Okay. CHO, it will transfer that hydride there. What it will form? HCO. Have I done? Huh. You are not telling me that I have made mistake. Huh? It will become HCOH plus C O negative H H. Now this O negative will abstract this proton and itself become alcohol and make anion of this. So which option is this? Concentrated NaOH is there. So student, option number B is correct. CH2OH and HCO negative. Clear now student why option number B is correct?
Yes, ma'am.
Okay. So what conclusion you can draw from here is, after doing many questions, you should write some conclusions in your copy. What? That if we are having two aldehydes, if we are having two aldehydes, aldehyde on which, or aldehyde which is more electron deficient will be oxidized. Correct or not? Are you with this statement? Other aldehyde will be reduced. Are you all with me for this statement? If we are having two aldehydes, aldehyde al- on which aldehyde is more electron deficient, it will be oxidized and other aldehyde will be reduced. So among these two options, which is more electrophilic? Aldehyde. So This is undergoing oxidation, HCO negative, and this aldehyde is undergoing reduction, forming alcohol. Clear?
Yes, ma'am.
Okay, very good. Today I will leave you early. I have some work. Okay. So let's complete it quickly. In option number A, you are having C7H14 that is going undergoing your ozonolysis reaction. You are getting two products. Compound A exists in geometrical isomers, okay, and B gives Cannizaro reaction. Okay. Would you like to take some time for solving this question, or should I start? Read this question. Are you solving, students?
Yes, ma'am, solving.
Okay, okay, do.
Ma'am, I think C will be correct.
C. Okay, she is saying C. Okay, first let's check. Is A having C7? So 3, 4, 5, 6, 7. Okay, 14. 3 3s are 9, 10, 11, 12, 13, 14. Okay, it is following the criteria. Now they are saying exist in symmetrical isomers. Yes, they can exist. So A is following all the criteria. B gives Cannizaro reaction in B plus C. Okay, so one will be like this CHO, other will be like CH3CHO. This can undergo Cannizaro reaction as it is not having any alpha hydrogen, right? In all other option, one will be aldehyde, one will be this will also be aldehyde. Okay, let's see this one also. 1, 2, 3, 4, 5, 6, 7. Okay, 9, 10, 11, 12, 13, 14. Okay, but student, why this can't be correct? Can anyone tell me?
Ma'am, it is not a geometrical isomer.
Exactly. You can't form cis trans or EZ for this alkene because it is having same substituent. Similarly, this is out, this is out. Only remaining option is this. This okay. 1, 2, 3, 4, 5, 6, 7. Okay. Other things are good. Why A is not correct?
Ma'am, there will be alpha hydrogen.
Exactly.
Then it will not undergo conjugate
In
reaction.
both the cases, there will be alpha hydrogen. Very good. C, CH3, C. They are having alpha hydrogen, but for Cannizaro, it should not have alpha hydrogen. So correct answer is option number C. Okay. Okay, students. After these 8 lectures, I will take one more lecture in which I'm going to revise all the week's lectures. Okay. Would you like that starting half an hour? Can I take one test? I will not mark. Just I will put questions here. You have to tell me answer. And after half an hour, we will discuss answer for all those questions. Will it be fine, or I should only give summary in that? Tell me. Yes or no?
Ma'am, after give summary, please you can take the test.
After giving summary, I can take test. You are saying.
Yes, ma'am.
Okay, we will decide. Next problem is, which one of the following compound is the best choice for being prepared by an efficient mix aldol reaction? Take it as your homework. I will discuss this in next class, okay? In short, it is asking which one of the following compound is best choice for by an efficient mixed aldol. Which reaction can be which beta hydroxy aldehyde or ketone best can be made by mixed aldol. Hint for this question is, when your mixed aldol will be best. Okay, tell me when your mixed aldol will be best. Obviously, when one of the carbonyl lacks alpha hydrogen. Yes or no? Then that possibility of self aldol will be eliminated, right? When you are taking two aldehydes or two ketones or one aldehyde one ketone, when your mixed aldol will be best, when one of the aldehyde or ketone lacks alpha hydrogen, so that it can't undergo self aldol reaction. It will only behave as your electrophile, and some carbon anion is going to attack your aldehyde. Clear? So I'm giving you hint for this question how you have to solve. I have told you in earlier last class. You draw starting materials for this. What will be the starting material for formation of these compound? Then see in which two component one is lacking alpha hydrogen. That will be most efficient mixed aldol reaction. I hope you understood how to start solving this question. If not, I will explain in next class. Okay?
Okay,
Students,
ma'am.
understood now what hint I have given to you?
Yes, ma'am.
Okay. Okay. This so you will tell. Number of intramolecular aldol react products possible. They are asking about possibility, okay? One possibility is this subtract proton from here, attack here. Only possibility. Okay. Another possibility is this abstract proton and attack here. This proton can be abstracted and attack here. So in total, three possibilities are there. Are you with me? Now your homework
Yes,
is
ma'am.
homework. Suno. Sorry. Listen, my homework is draw all the three products. Tell major and minor among them. Okay. Will you be able to solve that?
Yes,
Obviously,
ma'am.
obviously
Sure.
major will be where electrophile will be your aldehyde. But now think 1, 2, 3, 4, 5. Okay, 1, 2, 3, 4, 5, 6, 7. So major will be when this carbon ion is going to attack your aldehyde. So that will be your major. Okay, good. Now I think this is last. Yes. Question number 14. Draw the product form in each of the following directed aldol reaction. Okay. I will give you hint for this question. We will discuss this question in detail in next class. In next class, I will explain you what is kinetic enolate, what is thermodynamic enolate, when you have to form thermodynamic, when you have to form kinetic. Okay. But hint I can give you is, okay, LDA is there, student. From which side this LDA will abstract your proton, A or B? Now you will ask
B.
me, ma'am, what is
B.
LDA? You know now what is LDA? Lithium.
Yes, ma'am.
Yes, ma'am.
Okay, I think I have discussed in last class. Dioisopropyl. What is that? Amide. Okay.
Yes, ma'am.
Lithium positive. This is your bulky base. At minus 78, it will abstract proton from least hindered side. It will become form this enolate. Why LDA is good, student? Your enols are reversible, right? So in your enolate are irreversible. Once anion formed, it will not get back to its initial form. Okay. Now this enolate is going to attack your this aldehyde, cyclohexane carbaldehyde. What it will become? O negative, CH2, CO, CH2, CH3. It will take water and it will form this. Is first answer clear to you? In similar fashion, draw product for B and C. Okay. And if you have any doubt, you can ask me in next class. If you are having doubt regarding today's lecture, you can ask me now.